So in lesson 8.4, we're going to look at negative exponents. What produces negative exponents? How can we take negative exponents and rewrite them as positive exponents, but with an equivalent expression, so we haven't changed anything. And that's our big idea. We're allowed to do some of this manipulating because the numbers x to the negative n and x to the n are reciprocals. Just a reminder what reciprocals are. It's when you have a fraction like 1/4. The reciprocal is 4/1. They're not equal to each other. They are reciprocals. So the negative exponent property says x to the negative n equals 1/x to the n. Now this is really over 1, and so when you flip it, it's 1/x. So that's the reciprocal. Okay, so x to the negative n is equal to 1/x to the n. Basically, you're taking the negative exponent, you're bringing it to the bottom, or you're flipping the fraction because this is really over 1, and that makes it positive. So for instance, if I have 2 to the negative 2, following this set of thinking right here, x to the negative n, 2 to the negative 2 is equal to 1/x to the n. So 1/2 to the positive 2, which is 1/4. And if we go ahead and we plug that into our calculator, 2 raised to the negative 2, we get 0.25, which is 1/4. So we can see that these are equal to each other. So that's a special property that allows us to do some rearranging and simplifying in a way. And there's another property specifically for fractions when we're dealing with this. So x over y, we have a fraction raised to a negative exponent, negative n. That's equal to the reciprocal, y over x to the positive n. So if I wanted to create a positive exponent from a negative exponent that's on a fraction, I just take the reciprocal and it's going to make it positive. So for instance, if I have 5/2 raised to the negative 2, that's going to be equal to 2/5 raised to the positive 2. And if you plug that in the calculator, you're going to get the same answer for both. All right, so example number 1, let's practice rewriting these. So using our properties, a to the negative 3, if I want to make that positive, I'm going to use this property right here. So just like we did with 2 to the negative 2, which we can actually start with, I already did it. 2 to the negative 2 is going to be the same as 1/2 to the positive 2, which is equal to 1/4. And this is called a simple fraction. And so if you see somewhere in your homework or anywhere they ask for your answer to be given as a simple fraction, they mean don't leave an exponent in it. Go ahead and simplify it all the way. So following the same logic, a to the negative third is the same as 1/a to the positive third. So this is really over 1. Reciprocal, 1/a. Negative 3 becomes positive 3. Same thing here. This is really over 1. If I want to make this positive, I'm going to take the reciprocal and flip it. So 1/10 to the positive 4. Making it a simple fraction, I'm going to expand 10 to the 4th, and that's 10,000. So there's my simple fraction. Now for the last one, I've got a to the 7th and b to the negative 4th. So this whole thing is not made up of negative exponents, just the b. So while this is over 1, if I flip the whole thing, b to the negative 4th will become positive, but a to the 7th would become negative, and we don't want that. So we actually want to leave a to the 7th up top. So technically this 1 comes up here as well, but we don't need to write it in front. But b to the negative 4th will go to the bottom and become positive. So I have only flipped b to the negative 4th. So the main idea that we need to get out of this is that if you have a negative exponent and you want to make it positive, you send it to the bottom of the fraction. There are going to be times when you're going to start with a negative exponent on the bottom, and then you would send it to the top. So one common misconception is that anytime you see a negative exponent, you should send it to the bottom and it becomes positive. Well, that's only true if it's already on the top. If it's already on the bottom, you can't just leave it there and make it positive. In order to turn it positive, you'd have to send it to the top. So basically, they go to the top or to the bottom, and when they cross this line, they go from positive to negative or vice versa. So you got to send it whichever way makes sense. All right, example number 2, using the second property with our fractions. 5/4 to the negative 2, that's equal to 4/5 to the positive 2. We would want to expand that. So this exponent will go to both of them. So this is the same as 4 squared over 5 squared, not just the 4, but the 5 as well. And that's 16/5 25. So the next one, 2 to the 2/3 to the negative 4 is the same as 3/2 to the positive 4. So 3 to the 4th over 2 to the 4th. All I did was take that exponent and apply it to both the numerator and the denominator. So to the 4th to the 4th. And that comes out to 81 over 16. Notice I'm not writing these as some nasty decimal. If you tried to plug this in your calculator, you're not going to get a nice decimal most of the time. So we're going to leave these as fractions. This one, same idea. We're going to flip this to the reciprocal to make this positive. So n squared goes to the top, m is on the bottom, and now this whole thing is to the positive 2. So we've created the reciprocal. Now we want to actually bring in this exponent. So when it comes in here, we know when we take an exponent raised to another, that we multiply. So this becomes n to the 4th on top. But don't forget this has to also go to the bottom. And it's going to look like this. All right, what happens when there's more involved here? So we go to the bottom. We've got some bigger problems that start a little different than we were used to. So this looks very similar to the things that were on the last quiz from even 8.3. But what we want to do on this one, and actually all of these, we're going to write it two different ways. We're going to want to write it once as a non-fraction. And then part B with positive exponents. All right, so for part A as a non-fraction, 5 over 15, well, we know that equals 1/3. So we're actually going to throw that 1/3 up front, but we're not going to write the entire thing as a fraction. We're going to leave the 1/3 up there. So we're kind of used to canceling these 4 on top with 4 on the bottom. That's going to leave some left over on the bottom. But then that creates a fraction because we'd be leaving something on the bottom. So what we're going to do is we're going to follow our quotient property that says when you're dividing similar bases, the exponents are subtracted. So 4 minus 11 is -7. So this is a to the -7th. And now I have something that's a non-fraction. It's a negative exponent. But if I want a non-fraction, that's what I got to do. And then look at your b's. 7 minus 5. That's just 2. And with your c's, 2 minus 3 is -1. So there's your non-fraction answer. And if you wanted it with positive exponents, we're going to take this, and we're going to take our negatives and throw them to the bottom of the fraction. So now we're allowed to have a fraction as an answer. It's the only way we can get rid of these negatives so that we have positive exponents. A to the -7 goes to the bottom and becomes positive. C to the -1 goes to the bottom and becomes positive, and you don't even have to put the 1 there, but you can. 1/3, the 1's on top, the 3's on the bottom, and we're still going to have b squared up there. We're not going to do anything with it because it has a positive exponent. If you want to put the 1 from the 1/3 as a coefficient, that's fine, but you don't have to. All right, so let's do the same thing for the second one, A and B. So for A, we're going to write this as a non-fraction. So we're just going to go ahead and multiply here. X to the 3rd raised to the -2nd. Raising a power by a power, you multiply. So this is x to the -6. Non-fraction answer. Now, to make it a positive exponent, we're going to take that -6 and throw it to the bottom, and it becomes positive. And so it's 1 over x to the 6th. These are both good answers. These are both simplified. One is a non-fraction, and one is with a positive exponent. We need to be able to go between all 3 of these. All right, last one now. First thing I want to do on this is kind of get rid of this extra stuff that's on the bottom. So I'm going to leave the top alone. And I need to kind of work this out here. So I know that if I raise this power to a power, I'm going to multiply. So this is a to the -28. So now I'm going to go ahead and answer this 2 different ways. The one way, if I'm just getting rid of this as a fractional answer, so a non-fraction answer, the only thing that's making this a fraction is this a on the bottom. So what I'm going to do is I'm going to go ahead and use my quotient rule and do a to the 8th divided by a to the -28th, which means subtract my exponents. So 8 minus -28 is going to go plus, and that's 36. So I have 9, a to the 36th, b to the -2. So there's my non-fractional answer. Again, this is equivalent. All 3 of these are equivalent. And then if I want to give an answer that has only positive exponents, I'm going to have to make it fractional. This whole top, 9, a to the 36 is going to stay, but I want to get rid of this negative exponent. And so b to the -2nd comes down and becomes positive second. All right, let's go to the back and try some more difficult problems. So when we did this in class, I gave everybody 5 minutes to try these problems, and then we went over them after that. So I think the best thing you could do is pause the video and try these, and then press play again and see how you did. So I'll give you a second to pause it. And so now we're going to go through it. So hopefully you've already tried these, and now we're going to walk through the correct process. So when I'm looking at this, I know this -3 is going to have to go away. We're going to just answer these without negative exponents. So simplifying it and getting rid of those. So you could start moving it right now, but what I would recommend is first putting these y's together. So y to the third times another y to the third, that's going to be a y to the sixth. Now we can deal with the rest of this. So we've dealt with this, we've dealt with this. The biggest misconception I see on these types of problems is people want to move all of this, the 3 and the x, because they see the negative exponent. But that negative exponent is only on the x. It's not on the 3. This 3 actually has a positive 1 exponent. Now, if this was in parentheses raised to the -3rd, then all of it would be. But it's not. There's no parentheses, so only the x has the -3, which means this positive 3 coefficient can stay up here. Okay, it's not being raised to the 3rd power. It's just 3. Now, x to the -3rd, we want to make that positive. So all we have to do is throw it to the bottom. We have a positive exponent, and we're done. All right, so how about the next one? First, looking at the coefficient, 3 has a positive 1 exponent. That -2 doesn't go with it. So that's not going anywhere. It's positive. Let's leave it up top. Look at your x's. It's a -2 and a 4. So if you were just going to use the quotient property and subtract your exponents, -2 minus 4 is -6. So a -6 as an exponent is going to go to the bottom and become a positive 6. Other way to think about it is if you took x to the -2nd by itself and just brought it down so it became a positive x to the 2nd. Now it's on the bottom and you would combine this and this. You get x to the 6th and it just stays on the bottom. So that's another way to think about it. Now y to the 2nd, y to the 4th, you're subtracting. 2 minus 4, that's -2. Since you get a negative, you're going to put it on the bottom to make it positive. So y to the 2nd goes here. Or you can go back to the way we were doing it before. When you have two positives, you just cancel them out. So y to the 2nd is going to cancel 2 of these, and that means there's 2 left over on the bottom. All right, this one. Now I've got my parentheses being raised to a power, which means that this 2 actually is going to get this exponent of 3, and the v is also going to get this exponent of 3. So 2 raised to the 3rd is 8. V to the -2 raised to the 3rd, power raised to a power, I multiply. So this is v to the -6, and I still have v to the 3rd on the bottom. So at this point, you can either use the quotient rule and subtract, or take this v to the -6, put it on the bottom so it becomes positive, and now you combine them down there. So 8 is on top, and v to the 9th is on the bottom. If you were using the quotient rule, you would have done -6 minus 3 and got -9. And since it's a negative, you put it on the bottom to make it positive. Same thing. Now, this next one, you've got parentheses. And so this -3 exponent does go to everything, including this coefficient. And if you try and put 3 to the -3rd in your calculator, it's going to give you a nasty decimal. And so I never want you to try and punch in an actual number raised to a negative exponent, because it's hardly ever going to work out nicely for you in terms of giving you a good whole number. So what we're going to do is we're going to leave it for now just with the exponent. So it's going to be 3 to the -3. This is also going to come to the x, and so power raised to a power, you multiply. This is x to the -9th. Power raised to a power, this is y to the -6th. So far we've basically distributed that exponent. And again, you probably want to turn this into a number, not in your calculator though, because it's going to give you a nasty decimal because it's producing a fraction. So what we want to do, since all of these are negative exponents, is we want to throw these to the bottom. So what we're going to do is put them all underneath. So it's 3 to the 3rd, x to the 9th, y to the 6th. All the exponents became positive because we took the reciprocal, and so they're on the bottom. And now we can actually do something with 3 to the 3rd. 3 to the +3rd is 27. And so we can finally finish simplifying this. 3 to the 3rd is 27, x to the 9th, y to the 6th. So if you did try and put 3 to the negative third in your calculator and you get a nasty decimal, that nasty decimal is actually 1/27th. The fraction 1/27th, if you turn it to a decimal, it's going to give you the same as 3 to the negative third. Okay, but I want 1/27 because that's a usable number. This is now a usable fraction, whereas some crazy repeated unending decimal is not really going to help us. All right, last one. First of all, I see a 3 and a 3. They're simply going to cancel because 3 divided by 3 is 1. On the bottom, I've got two a's next to each other. Before I even worry about the negative, I'm going to go ahead and simplify and put them together. This is a to the first. And so since they are being multiplied, that means you add the exponents. 1 plus negative 4 is negative 3. So I have a to the negative 3 on the bottom. I still have a to the second on the top. So if I want to fix this, I'm going to just go ahead and I'm going to bring that up where it becomes positive, and now combine it at the top, and it's a to the fifth. Other way to think about it, if you don't like this process of bringing it up to make it positive and then combining, use the quotient rule. This is 2 minus negative 3, which is 5, and you have a to the fifth. So that's the other way of thinking about it. Also over here, if you didn't want to combine these first, if this negative was bothering you and decided you wanted to bring this up, you could have done that, and it would have been a to the fourth. And so when you put those together, that's a to the sixth. Okay, and then you still have this a on the bottom because we only moved the negative 4. This one's still there. So remember, this is a to the first. And so this 1 cancels one of these. So that's why your answer is a to the fifth. Or use the quotient rule, and 6 minus 1 also gives you a to the fifth.